Okay, good. So, good morning, and we have a leftover topic from last week, where we were studying asynchronous behavior and promises, and there's a, let's say, simplified syntax for handling promises that was introduced in the later version of JavaScript. From 2017, for example, by introducing two new keywords in the language called async and await, that actually give us a simplified way from the syntax point of view. Semantically, they don't change anything. So actually, the mental model of how promises work is exactly the same. But actually, we have this async keyword that will automatically create a promise whenever we create a function. For example, if I define any function, here we have a very simple arrow function that returns a string, for example, and we use the async keyword in front of the function definition. So whether we define it as a function or as an arrow function, with any function we define, we put async in front of it, and it modifies the return value of the function itself by returning a promise and not just a value. So in this case, it's a stupid function that will return a promise, and this promise in its body will resolve to the string test. So remember that the promise doesn't return any value, okay? Returns just the promise object, and then the promise internally may resolve or reject with some value, good value, or some error value. The work that we did last week of returning a new promise that would ultimately call resolve or call reject. Okay, so it's the normal way of having a function returning a promise. Okay, all this part, return new promise, is automated if you put async in front of the function. So an async function will automatically, when you call it, create a promise and return this promise immediately. Okay, when I call an asynchronous function, the function returns immediately, and the return value is a promise. Then inside the body of the function, I may have simply just a return statement that will be automatically mapped into a resolve for the promise. So inside an asynchronous function, when I write return, I'm actually calling the resolve method for the promise. And for rejecting the promise, I just have to throw an exception. So whenever an exception happens inside the function, the promise will be rejected. Okay, so it's just, let's say, sort of creating an implicit promise. We don't create the promise object ourselves. It's automatically created when we call a function. And let's see, for example, here, I can, sorry, let me find, okay, an example here. No, sorry, I want, okay, now, I wanted to discuss async before await, but now the slides are mixed up, so I will tell you also about the other keyword, await. Await is another construct, another statement that can be used in front of any expression of type promise. So await is a keyword, is an expression keyword, it's an operator basically that applies on promises. And it replaces the then callback for a promise. So normally we were used to say promise.then, and in the callback of the then we see what we want to do. Instead, await will actually stop the execution and let's say put the rest of the code of the function into an implicit then portion of the code itself. Await can only await for promises, so actually can only use when you have a function call to an async function or to any other function that returns a promise, and can only be used inside an async function. Since when I write await, I'm blocking the execution and waiting for the promise to resolve or to reject, my function itself, in which I wrote the await statement, automatically becomes asynchronous. It's no longer can no longer be synchronously executed from the first to the last line, as we said before. Okay, so there was an exception to the rule that we had until last week, where whenever I start a function, I always run it to the end. And the exceptions are async functions. Async functions that contain an await statement are, let's say, automatically broken by the compiler into many, say, sub-functions when we have the await statements. And each block will execute synchronously, but when I find an await, actually is like I am scheduling a different function. So actually this function will no longer be run synchronously and may be interrupted and may be put into await state. So this complicates a bit our mental model of how the call stack and the event loop works, especially await. Actually, the async keyword is just a replacement for create a new promise. Okay, await changes the way in which the code is executed, and can only, I repeat, be inserted inside an asynchronous function. So actually, imagine we have any asynchronous function. For example, this one is a classical one, return new promise. Okay. And I want to, for example, print something before this code and print something else after that. And this is a timeout. So normally this code will not work. Okay, if we write something before, we call the asynchronous function, the function that contains an asynchronous behavior, and we print the result. Normally, we know that the result will not be available here when you try to print it. Okay, we played with this before. With await, everything changes, so that actually when I call resolve after 2 seconds, this does its job, creates and returns a new promise. And the promise is still in pending state, it's not resolved yet. Will be resolved after 2 seconds, for example. So calling this function doesn't do anything special. But then we find the await keyword. Let's say, okay, let's stop the execution, put this function into hold, and only resume it only when this promise would be resolved or rejected. And at that point, the rest of the function is executed. So just imagine on this await, we'll break the function in two. The first part is the synchronous part. The second part is the, say, callback that is executed only after this promise is run. Semantically, it works in this way. Syntactically, it looks like we are calling synchronous code, and await is telling us, okay, the next statement, or also this assignment, will be executed after the promise is finished. Wait until the promise is finished and then continue with the execution. So we see that the code is much more linear. It's also more constrained because now I have to actually wait for the promise to finish before doing anything else. With the then keyword, I could have many promises running, and in parallel, for example, I don't need to specify that I need to wait for the first one before actually calling a second asynchronous function. Here is a bit more rigid, but it's clearer to the reader. Okay, basically. And as you see, the await keyword can only be used if the function containing it is declared async. So in this case, the function is not, we create an asynchronous function because the main code is not async by itself. It's synchronous, the main code, so it cannot call an asynchronous function. And sorry, you cannot call await outside of a function that we declare async. So it's just a different syntax. As you see, we can mix and match the two methods as we like. For example, we are using await on a function that is not declared async. It returns a promise, but being async and returning a promise is the same thing. So actually, there is always the promise object that handles this asynchronous behavior. In this case, we are explicitly creating the promise. In this case, async, we are implicitly creating a promise. And this promise can be consumed by an await statement, or can be consumed by a classical then statement. So for example, this call to the asynchronous function returns a promise. We don't see the promise, but it's implicit due to the async keyword. And the return statement will resolve this promise, and this will be the return value of the promise. And we can use the promise result with a then statement. So we can mix and match the promise and promise slash then slash catch, so the classical way that we had last week, with the async and await statement. Async will create a promise, await will consume it. It depends on whether we want or we don't want to manage the. So for example, this is an example of calling some API, asynchronous API, and then consuming the data. This is what we did before. This is what we can do now. Okay, we can await and then use the data that comes from this API. For calling await, remember that the function itself should be asynchronous. So the containing function, in this case, is make request function, is the normal function. If we want to use await, we must declare the function as asynchronous itself. But apart from this detail, we don't care whether this get API data is declared as an async function or as a normal function returning a promise. It's the same, okay? We know that it's asynchronous, we know that it returns a promise. So this is just, there's some comparison here about the explicit handling of promises or the implicit handling of promises themselves with await. So this is just a small issue that may simplify the code. Remember, we always need to think about promises that will resolve, and then we can write it in a simpler way. You see the rigidity that we have in the second version, because in this case you see that we have to wait the first one, and only after that we can work on the data from the second promise, which is the same that we did here. Okay, because actually the second call, like send email or get owner, can only be executed after we get the result of the previous one. This is how chaining works. But actually, if I had other code here in this function, get data, I could also schedule something else in parallel, to run in parallel. And then when it's resolved, the callback method will be called in sequence. In this case, actually, I'm blocked here on the first await, and I cannot have a function that tries to manage two different, let's say, asynchronous behaviors at the same time in the same function. Okay, it's more, I want to see it more looking like a sequential, and that means that I'm constrained to only have one thread. It's easier to think, it's less versatile, of course. Okay. Okay, these are just some examples that from now on we can use independently the two different methods. Okay, By the way, there are also, if you look if you want, there are some other libraries. SQLite 3 was the library that we use for the accessing database, which is based on the old style callbacks. Okay. Then we wrote some methods for returning promises, for making it easier for us to handle. There are also some other libraries. Here there are some links, but actually there are several wrapper libraries that already do this work for us. So they give us a promise-based API for SQLite if you want to use it, if you want to explore one of these. For example, this async or this SQLite without number 3, but actually they are wrappers similar to what we are normally doing. Okay, but they natively, let's say, use promises if you want. So just use the library that you want. Okay, so that was the last part from last week. And now we start actually thinking about the web architectures. Just remember that, and it's something that you should remember from the computer network courses, if it wasn't too long ago. Everything that we have in web application relies on a very simple protocol, okay, which is the HTTP protocol that lets clients and server communicate with each other. Okay, we are going to use let's say different features of the HTTP protocol just to let our front-end application, just imagine an application written in JavaScript running in your browser that needs to access some data or some functions that lives on a server somewhere else. And these two can only communicate through this HTTP protocol in different ways. Okay. So let's just give a short focus on HTTP, which is basically a request response protocol, where actually we have a request coming from the client to the server. Typically a request can be get something, and the server will respond after some time, of course, with a response message. And this closes the interaction. So I open a connection, a network connection, send a request message, wait a bit, receive a response, and then close the connection. Okay? Every interaction is done in this way, and every message exchange is independent from the others. That will create problems in the future, because every HTTP request is totally unaware of what we are doing. So maybe we are sending 100 requests from the same browser, from my application to the same server, and each of them will be treated as a completely new request by the server. There is no memory of what we are doing on the HTTP protocol, which is sometimes creates problem when we want to create actually this an application that shows you some memory of what we are doing with these. But we'll come to that. The request and response messages are very, very easily formatted. They are just text messages. There's no binary code. Yes, there can be compression, but it happens at the protocol level. From the message level, each message is just a block of text with the same structure. There's a first line in the request and first line in the response. There are some headers in the request and some headers in the response, and there may be a body in the request or in the response. So the format is the same for the request message and the response message. Of course, the format of the initial line and the type of headers changes, and also the semantics, the meaning of the body. From the request, the first line is always a command followed by an address, a method name. We will use different methods. Normally, the browser, when we navigate on the website, the browsers will just issue a get method for getting a new HTML page. Okay. When we are using HTTP as a client-server integration protocol, we will use more methods. That's the reason we are spending some time here. Okay, so there are different methods, different types of requests that the client can do, and these are actually the ones supported by the HTTP protocol, and the ones in bold are those that we are going to use. Okay, so it's not just get, which is the method that is used normally by the browsers, but we are also post, put, and delete with a different meaning, and others we are not going to use actually. We will exploit the HTTP protocol for a purpose which is different from the reason it was designed. Okay, when they designed HTTP, it was for downloading HTML pages in the classical, let's say, client-server behavioral web application. So the user sees a page, clicks on a link, and the link will bring you to a different page. So the browser requests a different page to the server, and the server will give the page again. It's a very limited interaction where the browser is just a passive device. When we have some application running on the browser, actually we have a software running on a node, another software running on the server, and the two need to communicate. And so we are exploiting HTTP, which was born for different purpose, for creating a channel by which two different applications can communicate, and the application running in the browser and the application running in the server. So we are in a way reinterpreting the meaning of the HTTP methods, where we are not using them for loading HTML pages anymore, but for exchanging data or for exchanging commands, or calling remote procedures and something like that. Okay, that's why we will define so-called APIs based on the HTTP protocol. And okay, the response also, we have a response line which contains basically a response code. We just remember that codes with the first digit equal to 2 means success, basically, and with the first digit initial starting with 5 means something was wrong in the execution of the call. If we are thinking about using HTTP protocol for calling a service or for requesting some data, the first one would be, okay, I have the result, and the second one would be exception, some exception occurred. And we can wrap them into a 500 status code or 200 status code. All the other code are rarely used, okay, in our application. We are not going into details about the headers, except that one possible header, there are hundreds of headers defined that are sent by the browsers or by the server. The one that is interesting to us is the content type header that specifies if we have a body in the response or a body in the request, which is the encoding of this body. Okay, so whether we are sending data encoding in JSON format or just in plain text or in binary format or whatever. And this will be important because then the client or the server will be able to unpack, to parse this data, knowing how it's formatted. It must be explicit. No? We cannot rely on auto detection or something like that. So this is a header that we will be careful to generate or to analyze the content type. And normally, okay, text HTML is the content type for HTML pages. That is handled by the browser itself. But we are especially working with the JSON format, where we are packing JavaScript objects into, we are serializing them into the JSON format normally. But we need to set that explicitly because the default would be HTML. And this works both ways when we are sending some information from the browser to the server. So we are putting some JSON inside the request body, or we are receiving some information from the server to the client, and in that case, we will have something encoded in the response body. Remember, request is from client to server, and response is from server to client. And so with this, we are using the HTTP methods, or verbs, to do different types of operation. Where we have a table that will tell us whether we can use some request body or not in the request or in the response according to the type of verb. This is a table that we use to decide which operation we can call. For example, a get method can have a body in the response but cannot have any body in the request, for example. It's just give me something. Okay. On the other hand, a post method normally sends some data. Post is the action that normally the browser executes when we click on submit for something. Okay. But we can create a post call in our code. We will learn how to do that. Okay. And so it's useful when we want to send, when we need to send some data to the server. And actually this method allows me to have some body in the request. And in many cases, the response doesn't need to have a body, but it may. So it depends on the cases. Post and put look very similar because they're both done for sending data to the server. And may also return some information, but they are not forced to. What is the difference between post and put? Well, practically they work in the same way, but semantically, one of them is idempotent and the other no. What does it mean? It means that by the design of the protocol, one method we call it idempotent if by calling it 2 or 3 times in a row, we get the same result. So, for example, if I have a get method that gives me, I don't know, the number of students, if I call it now, I get a number. If I call it in 1 second, I will get the same number. So, recalling the same method again will give the same result. Of course, unless the data has changed in the meantime. Okay. So the difference between post and put is sending data twice with a put method is the same as sending it only once. It actually implies a sort of a overwrite operation. I sent you some data and then send it to you again. You can maybe use it for updating or for overwriting the data that I sent before. So put is used for updating some information. Post is something that should not be repeated. Everything I post something, I'm creating new information. I'm not adding to or updating what we have. Okay? So post is something that semantically is something that I appending new information. I'm sending you new information, and if I post the same information twice, I will create 2 items, not only 1. Okay, so this is just interpretation, so from the text of the protocol description. But since it's a shared information, shared semantics, we will use this information when we are going to decide which HTTP method we are using for the different features of our application. Okay? Yes?
So if it is idempotent, if we did the same code twice, we have the same result?
The same result. Okay. Yes, if it's the same call twice with the same arguments, it's actually that idempotent means the same power, so it doesn't do anything as or more. It also gives some freedom. For example, making twice a get shouldn't change the result, and so also the browser can anticipate a get because you can cache it in advance because it doesn't do any damage to call a get statement, while sending a post will potentially create new data. That's why, for example, the browsers sometimes when you navigate back and forth tell you, okay, do you want to resend post data? No, there's a warning that the browser says, because the browser knows that sending some post information may change some data in the backend. So these are we'll come to this when we want to design our APIs and give a meaning to these operations. So this is the kind of low-level calls. We will not go lower than this level. So for us, HTTP will be the lowest level that will go, and that we see in web programming. We talked about the web server and the browser. The browser is already there. We just need to write an application. We will learn how to run the JavaScript in the browser next week. For the moment, we need to have a server to implement some calls. And for the server, we are using, since we are working in JavaScript, we are using a framework written in JavaScript, a very simple web server where we can implement stuff. Okay, and in particular, there are many libraries in JavaScript that work as web servers. We'll use the one which is quite simple and one of the most popular is called Express. Okay, so what is Express? Express is a JavaScript application that runs, that implements a web server. A web server is an application that is able to respond to the HTTP protocol. So it's able to receive HTTP requests on some address, of course, and create and send a response for that. The role of the HTTP server, or web server, if you want to call it like that, is to manage the HTTP protocol. And of course, give the programmer the ability of deciding which response to give, which is not, of course, a responsibility of the web server, because it doesn't know what we are doing. So it's the application code that we are going to write that decides, that computes actually the response. Okay, so Express is very easy to install. We just have to npm install the Express library. So let me see if I have the right folder open. Week 4. Okay, let's close it. Okay, so in the week 4, I already created npm init where I specified Express as the dependency. Okay, so I did this instruction, npm install Express. Let me run install so that all the module is downloaded. Okay, so in node modules it's okay, it downloaded some stuff. Okay, so we just create an npm project with npm init and then install Express, and then we are ready to go. By running the application, we just write some code into a JavaScript file and run it with Node. The server is something that will keep running, and maybe we will keeping to change it. If I run something and I change some code, it should stop the server and run it again. Okay, every time. That's why there's a tool which is quite useful called NodeMon, stands for Node Monitor, which actually checks your source file, and whenever the file is modified, it will automatically stop and restart the application. So it's easy, because when you save a file, it will restart the application. It saves you the hassle of stopping or forgetting to stop it and continue to debug the older version because you changed the file, but you didn't restart the application. But it's just a tip, okay? So if you install globally Nodemon, not just in this project, but it should be installed at the system level with the G option of npm install, and then use Nodemon instead of Node, it will do this for you, but just a tip. So how do we deal with how do we create a web server? Actually, it's quite easy. It just needs a couple of instructions. So Express is the package that we import. We can call the Express function, which is a constructor function, even if it doesn't have the capital letter, okay? And it will return you an application object. App will be your web application. Right now, it's created, but it does nothing. For running, actually running the application, you can call the listen method on the app object. And the listen by specifying the port, the TCP IP port in which you want to listen. Okay? By default, the official port for the web application will be port 80, but since we are just debugging and running development mode, we use another port which, if it's greater than 1024, you can listen to a port without having the root permission. Otherwise, you need to have system permission to listen on lower numbered ports. So usually with 3000, 3001, this range of numbers, okay, just for development. So when we call the listen method, actually the server is started and starts to listen to HTTP requests coming on that port. The callback is just something that is executed after the startup is done, okay? And this actually is sort of a blocking operation. If you run an operation here, and then the application will stop there, actually. Normally, it's the last statement in the code. In theory, it can receive any request on port 3000. Get something, post something else, or whatever. Normally, it will reject all of these requests because it doesn't know how to handle them. It will listen and refuse. 404, not found. Unless we register some route to respond to. So, for example, we want a website, the application to respond to the slash, to the home, say, address. We must register a route, so a part of the address that we want the server to respond to. And we can register them, for example, with app.get if we want to respond to the get method. It will be app.post if we want to respond to the post methods, and so on. By providing what? Of course, the URL, the portion of the URL that we want to listen for, that we want to respond to, and, surprise, a callback that will handle the request when it arrives. And the callback will receive two parameters, request and response, that are JavaScript objects that correspond to the HTTP request, so with the initial line, header, and body. So there will be methods for creating, modifying, and reading the initial line, the header, and the body. And of course, response, res, is an object that will contain, that represents the response being sent. The first parameter, request, is an incoming parameter. Is the request that we just received. We can use it for extracting information, for knowing what do we need to do. Response is an object that starts empty. It's an empty object that we need to fill with the information that we want to send to the client. Okay? So sort of a request comes in and a response should go out. The syntax of the application methods are very easy. No? We have app.method name. A method can be one of these, get, post, put, or delete. It doesn't change the behavior, it responds to different HTTP calls. Or we also have app.all that receives everything, and then inside the code you can decide. But normally it's clear if you specify which, okay, I am responding for a get method on this address, I'm responding for a put method, maybe on the same address, but depending on the method, we need to do something different. The address is actually the path inside the server that we want to match. There are some matching rules like a string or a pattern of a regular expression or something like that, just to say, okay, this code will respond to this set of URLs. And finally, the callback handler. Okay, there are all of these. And what we wrote here, I wrote a very simple, just cut and paste the code that is in the slide, for example, is I created the express, I listening on port 3000, and then I'm waiting for any request that comes on port 3000, the address is /, and this is the body that we are going to execute. So when the server is in listen mode, if we get some request, get /, then we execute this callback. And this callback will call the send method, in this case, on the response object. Say, okay, fill the body, the send method says, means that we fill the body of the response with this content, in this case a string, and send back the response. So close the HTTP connection by giving this response. We see in a moment the method that we can call. And if I run this, so let me open the terminal, node index. Oh, I see this server ready. Where does it come from? It comes from this callback. So actually the code has registered this route and started the server on this port 3000. And as you see, the terminal is not returning. So the server is still there running and doing nothing. Okay? So we need at this point some computer in the world that will call my computer by sending a GET request on port 3000 for the address /. Otherwise, we'll keep waiting for a century or so. We will learn to create a JavaScript application on the browser that will call this API. But for testing, I use a very nice extension that is called, where is that? Where is that? REST client. REST client is a simple extension of, you can use different tools. If you want to be fancy, there's Postman, which is a very complex tool for developing and debugging HTTP calls, okay? But this REST client is very easy to use. You just have to create a file with the extension .http. So I created a file, I called it test.http, and just you write what you want to execute. For in this case, you know, I want to test the GET operation on HTTP, the URL, localhost, port 3000 /. This is the GET that I want to do. I just write the initial line of the request here in this HTTP file, and you see that the extension creates a small link, send request here. So if I click on this send request, the extension will send an HTTP request to this address, and will show me on the side the response that I got from the server. So in this case, I got a response with the initial line OK, which is what the send method does. Remember, this code here this text here, is the HTTP response that was generated by where are you? By my web server. By here. Actually, by this instruction. Sorry, at this zoom level, it's very difficult to see more than one thing at a time. So this is the HTTP response generated by this send call that we have in the server. So what we did is that the client, in this case Visual Studio Code, sent a request to my server, which is our index.mjs running Express, on port 3000, and with the address /. You see it here. It has been received, and Express identified that the / is a registered route, and so it will just execute this callback. These are the headers of the response that have been inserted by Express on its own. And this is the body, an empty line that separates the headers from the body, and this is the body, which is actually the content of the send method that we created here. In this case, it's just a simple text body. It could be a JSON object, it could be any other type of content. It could be an image, it could be an HTML page. It's just a content that's being transferred. The HTTP protocol doesn't care about the content, the meaning of the content. It's just something that the client and the server should agree on. Okay, HTTP is just for transporting data. What happens if I try to call a different address? Where is that? Sorry, where is it? Here? If I call not /, okay, in this extension I can have more than one call, so I can have a file with all the possible tests that I can run, so it's very convenient. If I try to call a different port, where nothing is running, for example. So I need, sorry, to make 3 hashes for separating one request from the other, okay? So I need a request, 3 hashes for separating them, and so I see the send request here, and we have an error because the server is not running, connection was rejected, there's nothing working on port 3001. Okay, and if I call a different address, ABC instead of /, okay, what I get is a response, in this case, because I contacted the server running on port 3000, but the server Express itself, it is not my code, found that there was no route called ABC, and so it gave me a canned error message, cannot get ABC, no? Because 404, the path was not found. And the same is if I try to, on /, I try to, for example, put something, and again I will get an error, cannot put, in this case, not because the path is not defined, but because the method with the register is not defined. So very simple behavior. The Express checks if the path is registered, the route, they call it, is registered. If so, it will call the callback. What can we do with this parameter, request and response? These are the main methods that are available on the request object and on the response object. Request is for something to receive, so I want to extract information from it. Basically, what I could extract is the body. If the request brought the body with it, I can extract the body. Normally, we don't call directly the body method, but we want to parse it because maybe body is encoded in some way, and we see how to, for example, automatically parse the JSON and return in JavaScript objects. But this is the property that contains the body part of the request. There's these params and query that are 2 parts of the query, of the of the URL, of the address, that can be analyzed and can enable dynamic processing of the addresses. For example, the query is the part of the request after the question mark. So you know that URLs may have a question mark and then a set of parameters, and these are encoded with the URL encoding standard, and we can extract some information by using the query argument, the query property of the request object. So request.query will give us the parameters that were sent in the URL after the question mark. For example, if I have I don't know, user question mark name equal to Fulvio, for example. If I have a URL like this, I'm calling the user's address with some query parameters that are a couple of key value pairs. Okay? And these are parameters that are just passed to the server, and the server, in Express, we can extract this information to process it by request.query. And the other params instead are for a different strategy for passing information. So in this way, we have a URL which is parametric, contains some parametric data, and so that the same server can process this data. Another possibility is doing something like get, I don't know, HTTP localhost 3000, for example, users/20. Imagine that we have a user table and each one has a number and something like name. So you can encode, and we'll use a lot of this mechanism, encoding what we want to know in a URL where different segments specify, for example, the type of object, the identity of the object that we want, the one with ID number 20, and the property we are seeking, the name. Does it look like loading a web page? No. There's nothing to do with using the HTTP protocol for loading a web page stored in this address. We are just using the protocol for querying the server about some information that we want. And in this case, we have a pattern where all queries starting with users/some numbers must be processed by a given callback. So in this case, we have some parameters inside the URL that are different. The first one, the question mark syntax, is something that is encoded in the HTTP standard. The browser knows it. This is just an internal convention between our application that creates the query and Express that helps us to parse them with so-called named parameters in the route. We'll see how to deal with those. But basically, what we are doing is, in the request object, we are trying to extract information about the body that may contain information, the request parameters, or the request query parameters. There are parameters in both ways. In the first case, they are embedded in the URL syntax, and in the second case are coming after the question mark. And we extract this information. Then we process this information and use it, do our query into the database, we insert, we create, we compute, we check for errors, whatever we want to do. And finally, we must return a response to the caller. Even if there are some troubles, even if there are some errors, we always must return a promise. The HTTP protocol is not concluded until a response is received. Maybe an error response, maybe an empty response, maybe I don't have anything to tell you, but I need to still to send an empty response. Otherwise, the caller will still keep hanging, waiting for it. And then sooner or later, it will time out and give an exception, a timeout exception 30 seconds in the future when you are debugging something completely different. So always remember, every HTTP call must be closed. in many cases must also contain some content, some response. So for example, we have different ways of closing the response, creating and sending back the response, and we'll just send the response as it is. Maybe with no information, but just send us an empty response, sorry. And this is a bit bigger. Send creates a body and sends it. And so they're both, all these two instructions, well, we just finish the operation. It creates a response and the response is being sent. That's it. There's nothing more that we can do in the server after send, or they are sort of a return. Okay, calling send will create a body and send the response. Calling end will just send the response without adding new information. If we want, we can customize the response, for example, by specifying the status code. If there are something wrong, maybe we don't want to send a status of 200, we want to send a status of 404 not found, or 500 internal error, whatever, for database errors. So we can, on the response object, we can call the status method for specifying which status code we should return. Status only modifies the response without sending it yet. So that's why we are chaining it. Modify the status dot end. Modify the status dot send. So we are chaining some modifications until sooner or later we call send or end that will actually send or close the and also there's a shortcut called res.json that we call send, but send will usually expect a string. JSON will expect a JavaScript object and will serialize that JavaScript object into JSON as a string and then call send. And by the way, bonus, will automatically set the content type header by specifying that this is an object. We can try it. Let's imagine that we have a get http localhost. Then we can also use macros here to avoid repeating. Let's say user. Imagine that we have a call for giving me the current user. So I want to implement it. So I register another route, app.get user. So respond to any get call that you receive in the user URL by executing request response, this code. Imagine that we have an object describing the user, okay? So let user equal, maybe we want to query it from the database, but for the moment, let me just create it, something like name, Fulvio, and ID 123, and whatever. That's maybe all these two fields. Sorry, colon not equal. And we want to return this object, response.json u. So you see that u is a JavaScript object, maybe an array, maybe an object itself. It will be serialized into JavaScript, and if we run it, okay, not found. Why isn't it found? Because I told you before, and I forget myself, I'm still running the old version of the server. Okay, so I need to stop it, Ctrl+C, and run it again. And now it should work. Yes, it does. And you see that the response in this case was with a content type of application JSON and no longer HTML, which is the default. and the body itself is the JSON, the JavaScript description of the object itself. So it's an easy way of sending objects back and forth between, in this case, returning an object from the server to the client. .json will automatically serialize it and send it to the server, to the client. And then the client will have this piece of JSON which you can just parse it and have the object back. The data part of the object, of course the methods, the function properties will not be transferred, but the data properties are there. Okay, yeah, also the redirect. This is for returning, okay? How can we process some parameters? No? Like we said, how can we process the request itself? I said maybe we have the operation, I don't know, for creating a new user. Let's imagine it. Let me go to the HTTP file. I want to create a new user, okay? So I will maybe post into the user URL. For example, this has a totally different meaning, something like that. I want to post creating something new in the URL user. I'm reading this like I'm creating a new user. And for creating a new user, actually, I have to provide some body that describes the user itself. For example, the body could be some JSON code that describes name, Jim, and the ID is 99. This could be my body that I want to send. Of course, I need to tell the server that the body is encoded into JSON format. So I need to provide a content type of application JSON. So I'm actually writing here in plain text the content of the HTTP request. The first line, the headers that you want to add, and an empty line followed by the body. So in this case, I can send a request and it can be processed by the server. Now the server will need to parse the body, check the content type, and so on. There's some work to do when you receive something in input. And this work can be helped by a set of pre-processing steps that Express can provide us. Okay, we can do it by ourselves. Check the headers, find if we have an header called content type, and check the value, and so on. Okay, so work that we can do. Or we can rely on something that is already for us. There are some, the Express call them middleware functions. Some function that can be used for pre-processing the request. So doing something before I actually go to my callback. So something between when the Express receives the request and when my actual callback will be called. And these middlewares can do different stuff. They receive the request object, they receive the response object, and then can do stuff with this. They can do checks. For example, there are some validation middlewares. I want to check if the data is valid. Okay, there's a middleware for doing that. I just give them the rule and they will do the checks. I want to parse JSON, there's a middle for that. I want to log the calls, there's a middle for that, and so on. A middleware in Express is just a function that receives the two parameters, request and response. And imagine the request and response that you receive are the same object that every middleware receives, and every middleware can add or modify properties on those objects. So you receive some objects that have already been processed by some helper function. And okay, every function has a next method that we will call when it finished its own processing. Actually, next we'll say call the next middleware in line if there is more than one, or call the actual callback for processing the function. So actually, middleware functions are called in sequence until one of them decides to send a response to the client, and in this case it will close. So maybe it finds some error, so we can interrupt the chain. If the chain goes forward, every middleware, when it's successful, it's called the next function. Express will schedule the next middleware, and then the next one, and finally your code. Well, I'm sending your code for the call, but actually even your code can be a middleware. We can write middleware, they're just functions. We just need to be careful to call next at the end so that the chain will go forward. And for specifying which middlewares we want to use, we just put them, maybe a single function, maybe an array of functions, in the app.get or app.post route definition. So in this case, I'm saying register a route for method get on this path using this callback, but before calling the callback, call this middleware function that does something. And this function will be called on that specific route. Or if we want to apply a middleware to all the routes or to a group of routes, automatically without specifying them one by one, we can use the use method on the application, saying, okay, for all the routes that I'm registering now, for all of them, use this middleware. Or for all the routes that match this path, so only a subset of them, use the middleware. And so from that point on, all the routes will automatically call this middleware before your code. And it's quite convenient. So what are some useful middlewares? One is very easy. It's called static. So in this case, we know how to respond to a GET query by creating some response as a string. But maybe we want to return some static data, some text file, some image file, or whatever. That it can be just store it in some folder, and we want to Express just return the content of the folder, or the files contained in that folder. Okay, and so this is the word for the static middleware. Say, okay, everything, all files that are in folder public, which is below the current one, are automatically handled by Express. So if I have a get for a path name that matches one of the files that are stored into the public folder, Express will automatically take the file, encode it, and send it as a response without you doing that. Just serving static files on the root path or on a second level path, for example. We can actually, it's like mounting a folder onto a given URL address. If you want to return static data like CSS files, images, and so on. So we don't need to do any work for serving files. Otherwise, we will need to have our own small route registered on the name of the file, and then read the file from our disk, and compose the response and send it back. Okay, this is already done by static. If we want only to serve some files, of course, there's no intelligence here. We just keep the files and return it there. There's no processing involved. Or there are some middlewares for helping us to interpret the request parameters, some data that is coming in. And as I mentioned, the data can come in different ways. One is as query parameters. Like I said before, with a question mark, key value, a series of key value pairs. Okay? And they are automatically available on the request.query property. So Express is already parsing this. It will match the /login address. If we have something registered on app.get/login, it will automatically populate the query property with some sub-properties corresponding to the keys of the URL. So you see user here. So query.user will be automatically populated, and you can read that, and it will read actually the content FC in this case. So you can very easily, if you know which query parameters you are receiving, you just can extract this information, the data. Of course, it will all be strings. Okay, also 1, 2, 3 will be a string when you read it. But there's no middleware required. But in other case, like in our example, where we had some JSON that we want to pass in the body, there is some extra steps that can be done, should be done. And these extra steps are handled by the JSON, express.json middleware function. So what the JSON does is to check whether the request has a content type JSON that header. In that case, we will take the body, parse it, and in request.body will contain actually the JavaScript object corresponding to that parse string. Okay. For example, we wanted to create a user. Okay, so let's go to our web server. We want to create a app.post/user. And we know that this post user will receive a JSON body, so we need to enable the execution of the express.json middleware. We can do it for all the application. App.use. We register on all the application express.json, .json middleware. So with this line, we are saying that every time any route, before processing the route, check if some JSON body needs to be processed. Otherwise, the request.body property will be empty. Okay, if we don't do this. If we do this, then in theory, request response. Now we could, for example, see the request.body, how it looks like. And then remember to close the response, otherwise we are keeping, and just to see what is received here. Okay, so when I receive this, I check what is being put into the request.body. Let's stop. Okay, now I'm running with Nodemon, so every time I save, it will restart. I don't risk of forgetting. Okay, if I click on this post request, what I see is that on the console, I printed this. So this is the console of the server. This console.log request.body. So actually, request.body was populated with this object that we are lucky. It was exactly the same object that we sent in the request body here. And this response here, OK with no body, no information, is the result of end. So actually, this is on the server side. We know this information, we could create it into the database, and we are telling the client, OK, everything was fine. your request was executed correctly. Just remember to do that, because if I forget to register the JSON middleware and I save the file, I repeat it, and I see that the body is undefined in this case. So it's not automatically done by Express itself, it's done by this middleware. And also, if I forget in the test code to set the content type, let's say if I'm forgetting this, and in this case it's returning an empty object because the JSON middleware is registered, but it wasn't actually triggered because it didn't see the header saying, okay, you need to process this. It doesn't just try to blindly process everything, only something that is tagged in the right way. And now it should be working again. Okay, so this is an easy way of receiving also information. If the information is simple, we can encode it into the URL, and it will be then inside request.query. If it's more structured, like in many cases, we can put it into the body. And remember that the body can be applied to all methods except get, and extract it with request.body, and then the sub-properties that we can have from there. Up to now, we just use simple paths, simple strings as paths, but actually, like I mentioned, you can have also regular expression or something more complex, a list of paths that help us to actually execute the same callback on a set of different or similar addresses or group of addresses. But the interesting part is if when we want to have a structured URL, like we had before, that contains some fixed parts and some variable parts, some parameters. Like I imagined here, users 20 name, for example. So I want to write a callback that will respond to every URL that contains users slash some number slash name. And I can construct that in Express by using this syntax with the colon symbol. So it's a sort of a named wildcard, or named parameter, like they call it. Every piece of a URL that contains a colon is just a parameter. And so this get path will match everything that looks like slash user slash anything slash books slash anything else. And it will store into request.params.userid the anything in the first block, and inside book ID the anything else in the second block. So it's another extra easy way of extracting some parameter from the client. So in this case, I need to register if I want to run this, get the name of this user. I need to register app.get, something that looks like user slash colon ID slash name. And then we have the callback, request response. That will extract the ID, const ID of the user, from the request.params.id. And from this ID, we can construct the user information. We now query the database, do everything we need, and then we return response. Remember, request is from you get information, and a response is where we prepare the result. JSON and we can pass an object with the ID field equal to our ID and the name equal to Tom, for example. Imagine that Tom comes out from a database query. And so if we try to run this, not user, sorry, I need to, okay, so it returned. In this case we meshed it, and you see that the response contains ID 20, that shows that how this number 20 has been extracted from the parameters of the query. So we can have a full family of URLs that look alike, and have some segments of it that are parametric. We'll exploit this a lot in defining our API design, API interface. One last middleware that I'm going to use a lot is Morgan. Strange name. I think actually it does something very, very useful, which is logging all the requests. So right now, when you click on a request, Express doesn't print anything. Okay, the console is empty except from this server ready at the beginning, and maybe if we log something ourselves. Okay, but it could be useful, especially when you're trying to see which requests are coming through. Okay, and this is just this Morgan, which is not part of the Express library, so you need to install separately. So you need to stop the server, go away, stop the server, npm install Morgan, then restart the server, and they can import Morgan from Morgan and app.use Morgan. Okay, should work in this way. And from this moment on, whenever we call an API, it will print a line on the console that will show what it received. Now it's complaining because, okay, in the constructor of the Morgan library, it should specify a format. I just put an empty parameter. I should provide a parameter that will tell which format. For example, there are different predefined formats. Let's put in development mode, so Zapier. And okay, we see some information. Depending on if you check the Morgan documentation, there are several formats that you can customize to see how much data you want to see in every row. Okay, but it's useful, especially in debugging, to have this on. When you don't want logging anymore, you just remove the app.use line and it's done. So that is just another functionality. Later on, we'll check on the input validation. That's a very nice Express validator that is useful for checking and validating input data in parameters, in queries, and in the body. So actually very powerful. It saves us from having to do a million checks on input data. We just define the rules, check that this field is present, and these are, it looks like an email address, check that this is a password of minimum size, and so on. So in a very declarative way, we see which are the checks, and it will be done automatically by calling this very simple validation results method that will tell us, okay, is it okay or not? So it's very useful if you want to validate some inputs, and there are, of course, other middlewares that we can play with. Okay, so our next steps after the break will be try to use this basic knowledge of how to create some responders to HTTP calls to help us design how the server for our question and answer website, for example, would work. We have a database with questions, answers. We want to enable a client running on a browser to access this information into the database. We providing some endpoints that we can call to read, modify, and so on, the data in the database. So that's for our job for after the break. 50 minutes as usual.